Okay, so let's continue. Besides and or, there are things we want to record, like the probability of something happening at least once. We don't care how many times exactly, but at least once, or no more than a certain number of times. So we have to have some reasoning behind how this works. So let's look at the spinner on the right with the red, blue, and green. Let's say the spinner is spun 2 times. Find the probability of spinning at least 1 green. Let's look first at all the possibilities. There's blue, 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 red, blue, green, red, blue, red, 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 green, green, blue, green, red, green, green. This says at least once. We don't care if it's once or twice. Looks like we've got 5 out of 9 have at least 1 green. So let's think about this. What are the chances of getting at least 1 green plus the chances of no greens? Well, at least 1 green was 5 out of 9. No greens was the other 4 out of 9. Added together, they are 1. So what does that mean? Well, it means none and at least 1 are opposites or complements, so we know that they always add up to 1. So sometimes it'll be easier to find the probability that there are no greens algebraically and then subtract that from 1. So just let's subtract probability of no greens from both sides. That means the probability of at least 1 is equal to 1 minus the probability of none, generally. This is always true. Now what's the probability of not spinning a green in 2 spins? Well, we first need to calculate the probability of none. If there's 1 out of 3 options is green, that means 2 out of 3 is not green for each spin. 2/3 times 2/3 is 4/9. And that means 1 minus 4/9 is our 5/9. So this is the way it works for at least once. It's almost always going to be easier to do if you can do just one calculation, none, and then take 1 minus that. It's usually the easiest way to go about this type of problem. Because especially in situations where there are more than 9 possible outcomes, you don't want to have to write everything out and count them. For example, the spinner is spun 4 times. Find the probability of spinning at least 1 green. Okay, so what are the chances of, we have to do 1 minus the probability of no greens. So what are the probability of no greens? In 4 spins, means it's 2 out of 3 times 2 out of 3, 4 times, which is 16 out of 81. So we take 1 minus 16 out of 81. That's 81 out of 81 minus 16 out of 81, which is 65 out of 81. Or I think this is just a shade above 0.8. Well, let's get the decimal just in case. 0.802. So it's really that easy, but you don't want to have written all 81 combinations out and counting which ones don't have any greens. That would not make me or you happy. The coin is tossed 10 times. Find the probability of it flipping at least 1 heads. What are the chances of not getting a heads in 10 flips? Well, that'd be 1/2 getting tails to the 10th. So 1 minus 1/2 to the 10th. Just 1 minus 1 over 1,024. If you put it into the calculator, see what 2 to the 10th is. Or 1,023 out of 1,024. This is an incredibly large number, like 0.999. 0.999. Guys, it's really hard to flip 10 tails or 10 heads in a row. Really, really hard. Not super likely to happen, just saying. This is why you can't really go into a test on a true-false test, even a true-false test that's 10 questions and know nothing, because only 1 out of 1,024 times in a 10-question test could you actually get 100. So you have to be aware of these things. Okay, let's do another example. Christmas lights are often designed with a series circuit. That means if one bulb burns out, the entire string of lights goes black. I know all of you have experienced this over the holidays if you've hung lights up where you try to unscrew each bulb and see, hey, is this the broken one? No, let's try the next one. Suppose the lights are designed so that the probability a bulb will last 2 years is 0.995. The success or failure of the bulbs are independent of each other. Like, what kind of design is it that where one goes out, all of them go out? I don't know. But it was a thing. What is the probability that in a string of 100 lights, all 100 will last 2 years? Well, the chances that any one will last 2 years is 0.995. And how many different bulbs do we need to do this? 100. So that is 0.995 to the 100th power. 0.6058, 0.606, approximately. What is the probability that at least one will burn out? Remember, at least one, this is all of them will last. This is at least one will not last. Those are opposites, so it's 1 minus part A, up above. So 1 minus 0.606, which is 0.394. And that is it for this section.